Good morning, dear students. Okay, so in the last class, we have completed the chapter aldehyde, ketones, and carboxylic acid. Okay, I have uploaded the notes also. So please go through the notes. Did you find any difficulty in the previous chapter? Yes, because we are going to start with a new chapter today. So this is from inorganic chemistry, that is coordination chemistry or coordination compounds, you can say. Okay, coordination chemistry or coordination compounds. In your this it is coordination compounds. So let us write it as compounds only. Okay, coordination compounds. Yes, fine. So let us start with a new topic today, that is coordination compounds. Okay, so what are these coordination compounds? So these are the special class of compounds. Okay, so these are the special class of compounds in which you have heard about ionic compounds, you have heard about covalent compounds, right? So how covalent compounds are found, how ionic compounds are found. So these all things you know. Similarly, so these are a special class of compound, okay, in which the metals, okay, or the metal ions, okay, these are bonded to a number of anions or neutral molecules, okay. So these are bonded, okay, so these are bonded to what? These are bonded to your, so centrally a metal will be there, okay, in the center metal will be there, and this central metal, it will be bonded to what? It will be bonded to the, okay, by ligands, okay, or you can say now they have told you as anions or neutral molecule. Anions means what? Anions means the molecules which are having negative charge, right? And neutral molecules means molecules means they do not have any charge. For example, your H2, for example, your ammonia. Okay, so they do not have any charge. Anion means what? Cl minus, F minus, Br minus. Okay. So these are all your what? Anions. Okay. So these are all your anions. So what are complex compounds? So complex compound, it is a special class of compounds in which, okay, or you can see, so in the center metal is there. Okay. In the center metal is there, and these L means what? L means the anions or neutral molecules, they are termed as ligands. Okay, they are termed as what? Ligands. So metal is in the center and surrounding, okay, the surrounding what are present? Ligands are present. And these ligands are what? Either they are anions, that is they are negative charge, or they are neutral molecules. Okay, so these things you have to remember. So if anybody asks you what is coordination compound, so coordination compound, it is a special class of compound in which your metal, okay, metal ion is in the center, okay, and surroundingly what is present? Ligands are present, and these ligands are what? These ligands are these ligands are what? Either they are anions or they are neutral molecules. Okay, so this you have to remember. Okay, so this is about your coordination compound. So in the modern, so they were previously termed as complex compounds. Okay, previously they were termed as complex compound, but today in modern terminology, these compounds are called as coordination compounds. Okay, so in today's, so the bond which is formed between this metal and this ligand, right? So this bond which is formed here between the metal and the ligand, this is called as coordinate bond. Okay, it is called as a coordinate bond, or it is called as dative bond, or it is a dative bond. Okay, so remember that how ionic bond is formed. Yes, let us recap how ionic bond is formed. Ionic bond is formed between the ions. Okay, a positively charged ion and a negatively charged ion. So what is happening? Equal sharing of electron takes place. Okay, so the transfer, not sharing, transfer of electron takes place. Okay, transfer of electrons takes place. So Na plus will lose a electron and Cl minus will take one electron. So there will be transfer of electron taking place in ionic bond. Now, next also we are discuss about called covalent bond, right? We might be knowing about covalent bond. Covalent bond means what? Yes, so one H plus and one, no, let us take as CH4. Let us take as CH4. Okay, methane. So what is happening here? What is happening? So sharing of electron takes place. Okay, sharing of electrons takes place in your methane molecule. So carbon will have four electrons. Hydrogen, okay, there are four hydrogen. So each hydrogen will have what? One electron, right? So one, and one electron. So what is happening? Sharing of electron is taking place. So a covalent bond is formed between these this what methane molecule. So it will have a what structure? It will have a tetrahedral structure like this. So whatever these bonds are formed, these are called as what? Coordinate covalent bond. Understood? What is ionic bond, what is covalent bond, and what is coordinate bond? So what is coordinate bond? So complex compound, okay, which is in which the central metal ion is present or metal atom is present, and they are surrounded by number of anions or neutral molecules which are termed as ligands. Okay, and the bond which is present between the metal and the ligand is called as a coordinate bond, or it is called as what? Dative bond. Okay, so previously it was called as complex compound. Now it is termed as coordination compound. Is it clear? Yes. So this is about your coordination compounds. Okay, so introduction. So small introduction. Okay, to the so what is coordination compounds? Okay, is it clear? Okay. So usually when two or more stable compounds are mixed, suppose now there are some two or more stable compounds are there. Okay, some stable different compounds. Suppose I have NaCl, I have KCl, I have Na2SO4. Okay, I have KNO3. So these are some separate compounds, right? Suppose I mix some three compounds. Okay, I have some three two or more, these are compounds, right? So separate compounds. So when these are mixed, okay, when they are mixed in one ratio, okay, in a proportionate ratio or stoichiometric ratio. Suppose I want 2 moles of KCl. Suppose, okay, I'm taking an example. I suppose I want 1 mole of this and I want 3 moles of this. So in a proper stoichiometric ratio, if you're mixing them, okay, then they are called as addition compound. Then they are called as what? Addition compounds. Okay, so whenever I have two or more compounds and I mix them in one stoichiometric ratio. Stoichiometric ratio means what? Stoichiometric ratio means in some proper terms, means 2 moles of KCl, 1 mole of Na2SO4. Stoichiometric ratio means this represents your stoichiometry. Okay, how many moles are present? Okay, of that particular compound. Stoichiometry means that. So when we have stable compounds, two or more stable compounds, okay, these stable compounds, if we mix them in a stoichiometric ratio, then a new crystalline compound is formed. Okay, and these compounds are called as addition compound. Now these addition compound, these are of two types. Okay, these addition compounds, okay, they are of two types. One is the double salt, another is the complex compounds or the coordination compound. Okay, understood? So when two or more stable compounds, okay, stable compound mixed in a stoichiometric ratio, okay, stoichiometric ratio, new crystalline compound are formed. Okay, and these are called as what? Addition compounds. Okay, so now these addition compounds are of two types. One is your double salt, another is your coordination, or I'll write it as complex compounds. Okay, so let us discuss about double salt now. So these are the addition compounds. Okay, this will dissociate completely into its simple ions when dissolved in water. So double salt means what? Double salt. Okay, the word itself tells you double salt means what? Consisting of more than one salt. So when you have a double salt and when you add it in water, what will happen? It will dissociate. Suppose, okay, let me give you an example of a double salt. So take an example of double salt like your carnallite. Okay, carnallite. So this is one example. It consists of KCl, MgCl2, and 6 moles of water. Okay. Now this carnallite, okay, if you add it in water, okay, if you add it in water, it will dissociate. Okay, it will dissociate. Okay, it will dissociate into its simple ions, that is K plus Cl minus plus Mg plus 2 plus 2Cl minus. Okay, so like this, it will dissociate. So whenever double salt is there, if you add it in water, what will happen? It will completely dissociate into its simple ions. Okay, so these are the examples. So let me give you examples. So this is a carnallite. Okay, so this is a carnallite example that is of double salt. So then is more salt. So more salt is given here. See FeSO4 dot NH4 twice SO4 dot 6H2O. So this is the example of a double salt. Very important. You should know the formula of more salt. Mark this as important. Important. Please remember this. Okay, one more question. What is the formula of more salt? FeSO4 dot NH4 twice SO4 dot 6H2. Okay, so you need to remember this. 4.6H2O is nothing but your double salt. So more salt. Okay, very, very important. More salt. Okay, next. So we have seen carnallite, then we have seen more salt. Okay, more salt. Then next is your potash alum. Okay, another example of a double salt is potash alum. So what does this consist of? It consists of K2SO4, okay, dot K2 dot Al2 SO4 thrice dot 12H2. Okay, so this is our what? Potash alum. So what does potash alum consist of? K2SO4 dot Al2SO4 thrice dot H2O, 12H2. Okay, so these are the what? These are the your what? Examples of double salt. So what is a double salt? Yes, so double salt is what? So double salt. So when two or more stable compound form, they form the stoichiometric ratio. Okay, so here you can see double salt. They are compounds consisting of two or more stable compounds. Okay, so when you add them in water, they will dissociate into its simple ions. Okay, so these are called as double salt. Please remember these example: more salt, potash alum, and carnallite. Okay, so these are the examples of double salt. Okay, is it clear? What is addition compound? What is double salt? So next we are going to move for what are complex compounds. Okay, what are complex compounds? Now, what are these complex compounds? So these are also the addition compounds. Okay, these are also addition compounds, but they will not dissociate. Okay, they will not dissociate into simple ions. Okay, it will not dissociate into its simple ions. So they will not dissociate into simple ions when dissolved in water. Okay, but what they will produce? But they produce complex ions. They produce complex ions. Okay, I'll tell you what do you mean by this now. So these are also coordination compounds are also addition compound. But when you add them in water, they will not dissociate into simple ions. Now here what we had seen, KCl dot MgCl2 dot 6H2O. Okay, when you add it in water, what will happen? It will dissociate into its simple ion, K plus Cl minus plus Mg plus 2 plus 2Cl minus. Okay, like this, it will dissociate into its simple ions. But these coordination compounds, they will not dissociate into its simple ions, but instead of that, they will produce complex ions. Okay. Now, for example, let me give you example. Here I'll write it. K4FeCN6. Okay. So this is a example of a coordination compound. Now, if you add it in water, okay, the name of this compound is potassium ferrocyanate. Potassium ferrocyanate. Okay, how to name this compound? We are going to study in our next classes. Okay, IUPAC nomenclature of coordination compounds, very important. So that also we are going to study. So what is coordination compound? So so these are also addition compounds. When we add it in water, they will not dissociate. They will not dissociate into it simple ions, but they will produce the complex ion. What they'll produce? They'll produce complex ion. Okay. Fine. Now, example, so when you add it in water, what will happen? Just see. So K4FeCN6, when you add it in water, it will dissociate into 4 K plus ions plus FeCN6 4 minus. So like this. Okay. They do not produce the simple ions. They instead produce what? They'll produce complex ions itself. So you can see that it is not dissociated completely. So they are in the complex form, right? So this is an example. One more example, let us take second example, CuNH3 4 SO4. Okay. Now this is another example of a coordination compound. So this, when you add it in water, this will dissociate into CuNH3 4 2 plus SO4 minus 2. Okay, so this is another example of what your coordination compound. So remember what are coordination compound and remember one example. Important. Okay, important. What is coordination compound? So these are the addition compounds. When we add it in water, they will not dissociate into simple ions, but they produce complex ions. Okay, please remember the examples also. So one mark question. Okay, very important. So what is the name of this particular complex? It is ammonium, cupra ammonium sulfate, cuprammonium sulfate. Okay. So naming the compound, we are going to discuss. Okay, fine. So is it clear up to what are addition compounds, what are double salt, what is coordination compound? Yes, with the examples, everything is clear up to here. Okay, okay. Others, Yamuna and Harshita have understood. What about others? So if you find any difficulty at any point, you can ask. Okay, don't be shy. So this is a very important chapter. So this consists of 12 marks. Okay, very important and very scoring. If you understand this particular chapter, you can score very well in this particular chapter because this is one of the interesting chapter. Okay, applied like okay. So you will not feel bored in this chapter. It is very interesting chapter. Fine. So let us move forward. Yes. So just now what we had discussed, the same they have given. Now suppose I have potash alum, okay, and if I add it in water, okay, how it will dissociate? It will dissociate into its simple ions. You can see 2K plus 2Al plus 4SO4 minus 2 and 24H2. Right. So this is the way when we have a double salt. Okay. So when we have a double salt, what will happen when we add it in water? It will give you it will dissociate into its simple ions. Okay. Now, on the other hand, when we have a coordination compound, what will happen when we have a coordination compound? Even when you add it in water, the molecular compounds, okay, they will retain their identity. Okay, they will not completely dissociate it, right? So we have seen K4FeCN6. So when we add it in water, what is happening here? K4 plus, right? 4K4 plus Fe CN6 4 minus. So even if you add it in water, what is happening? The molecular formula or the molecular compounds of this, okay, they are retaining their identity. Okay, it is showing that it is a complex compound. So complex compounds, they will retain their identity even if you dissolve in water. So, so that the example here you can see that is when potassium ferrocyanide is dissolved in water. Okay, it will not give you Fe plus 2 and 6 Cn minus, but instead it will give you 4K plus FeCN6 minus 4. Okay, so this shows that it is a coordination compound. Okay, it is retaining its identity. So this is a difference between the double salt and the coordination compound. Okay. Yes. So as we know, so the compounds that have a complex ions, right? Just now we saw example of a complex compound. So when you have a complex, so this is what Fe. So let us take this example only. Okay. Now a compounds which has a complex ions. Okay. It has what? It has a complex ions. You can see what are the complex ion here. Here the complex ions are this. Right. So the compounds which have a complex ions. So these are termed as what? These are termed as complex compounds. Okay. These are termed as what? Complex compounds. Okay. So here in this complex compound, so there will be what? The central metal ion in the complex ion. Okay, so central metal atom is there. Okay, in the central metal ion is there, and surrounding what is there? Surrounding the ligands are there. Okay, surrounding the ligands are there. So between these ligands and the metal, there is a one type of linkage, or there is a one type of bond which is formed, and this bond is called as what? A, uh, a coordinate covalent bond or dative bond. Okay, covalent coordinate bond, coordinate covalent bond or dative bond. So complex compounds are found how? In the central, your metal atom or metal ion will be there, and surrounding your ligands will be there. These ligands will are what? These are either anions or they are neutral molecules. Okay, they are neutral molecules, and they are these two are having a special bond which is called as a coordinate covalent bond or a dative bond. Such compounds are called as what? Coordinate compounds or complex compounds. Okay, coordinate because it is forming a coordinate bond between the ligands and the metal. So it is called as a coordinate bond. Okay, is it clear? So if from this, so if I take this particular example, our example, how we are supposed to write. So Fe will be in the center. Fe will be in the center, students. Okay, and you have CCN. You have what? You have your. Just a second. I'll take this. So I have CN, 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 CN. Okay, so these are our 6 CNs. So 1, 6. Okay, And so, and what is there? Your complex is there, and your what is there? Minus 4. Okay, minus 4. So because you are not writing K4, then you have to write here minus 4. So this is our coordination compound. Is it clear how to write the coordination compound? So in the central, your metal will be there and your ligands will be surrounded by the metal, and it is forming what? A coordinate bond or a dative bond. Okay, such compounds, they are called as what? Coordination compounds. Is it clear? Okay. So before going to the theory, okay, before going to the theory, first we will see some terms. Okay, let us see some of the terms which are involved here. Potential entity, central activity. Okay, so we are going to see some of the terms first. Okay, then we will go. So the first, so which are some important terms which we are going to use in coordination compounds. So the first is the uh, coordination entity. Okay, coordination entity. So coordination entity means what? It is an ion or a molecule, okay, which is consisting of a central metal atom or the ion bonded to fixed number of ligands. Okay, so means what? In the central, so what is coordination entity? So it is a ion or a molecule. Okay, it is an ion or a molecule consisting of a central metal atom or ion which is bonded to fixed number of entity. For example, okay, CO, NH3, 6, 3 plus. So cobalt, okay, so cobalt is bond to 6. So this fixed number, okay, so this fixed number, okay, of the central metal which is bond to its ligands is called as the coordination entity. So like this is the coordination compound, okay, what we write. Now here the number of NH3, okay, and your cobalt, it is fixed. So how many NH3 should be linked to your cobalt? So that is fixed. Okay, it forms a six coordination number only. So the compound which is formed with cobalt will be in six coordination number. Suppose I have a nickel tetracarbonyl compound. Now here what you can say that nickel is in the center, okay, and you have four carbonyl groups. You have what? Four carbonyl groups. Fine. So this is another complex. This is another complex. Then we have what? Let me clear this. We have FeCN6 3 minus. Now, how we would write this? Fe in the center, 1, 2, 3, 4, 5, 6. So Cn, 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 and Cn. Okay. So here minus 3 minus. So this is, so here the metal atom or the ion which is bonded to fixed number of this is called as the coordination entity. Now again, one more example I can give you. Cobalt, okay, Cl, Cl, then NH3, 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 and Cl. Okay, so this is another example. So like this is your coordination entity. So this is a, so the fixed number. So here the Cl and NH3 ions are fixed. So the fixed number of ligands attached to the central metal atom is called as the coordination entity. Okay. The next term which we are going to use as the central. Next is the central ion. Okay, central atom or central ion. So this metal which is there, okay, which is it is a metal atom. Okay, it is a metal atom. So this is a metal atom which is there in the center. Okay, so the metal atom or the ion in which the number of ligands, okay, are bonded in a definite geometrical arrangement around it in a coordination entity is called as the central atom or ion. So the number of ligands which are present, which are attached to the central atom, so these are in a proper geometrical manner. You can see how they are arranged, right? So the distance between the each ligand, it is same, right? So they have arranged in a proper manner. Okay, so this proper arrangement around the coordination entity is called as the central atom or ion. Okay, so now in this complexes, can you tell me which is the central atom? Okay, I'll give you some of the complexes. You have to tell me which is the central atom. Yes, tell me. So in this complexes, which is the central atom? Ni. Okay, very good. Then second one, very good. Cobalt. Yes, very good. Third one, Fe. Very, very good. Yes. Okay. So understood. I hope it is understood. So it is a central atom or the ion to which the fixed number of ligands are bonded in a definite geometrical arrangement. Okay. In a coordination entity is called as the central metal or the ion. Okay. Very good. So these are the central atom or the ions which are involved in this particular complexes. Okay. Next term is ligands. Next term is the ligands. Now, what do you mean by a ligand? Okay, the ion or the molecules which is bonded to the central metal atom or the ion in the coordination entity is called as the ligand. So, the molecules or the ions, okay, which are coordinated to the central metal atom or the ion in the coordination entity. So, these are called as what? Ligands. So ligands, as we know, so these are either anions or they are either neutral molecules. So either of this, either they can be anions or they can be a neutral molecules. So it should donate. So this, what is the condition for the ligands? So it should donate one or more lone pairs. It should donate what? One or more lone pair of electrons. Okay, it should donate one or more lone pair of electrons to the central atom, okay, or ion. Okay, so that it can form coordination bond. So that it can form. Oh, okay, so this ligand should give electrons to the metal so that this bond, that is a coordination bond, is possible. Okay, why? Because only because of this coordination bond, okay, the ligand and metals are bounded. Okay, so this is a donor atom or donor cell. So this is a donor atom or donor cell. So what is done here? So it donates one or more lone pair of electrons to the central atom or ions. Okay, is it clear? Is it clear up to here? Okay. So the molecules or the ions which are coordinated to the central metal. So here, can you tell me? So K4FeCN6. Okay. So how many ligands are there? There are six ligands. Cn is the ligand and there are six cyano groups which are coordinated. So will be in the center. Fe will be in the center and here your six, this will be there. What? Cyano groups will be there. Okay. These are the six cyano groups. Okay, so like this, it will form the coordination compound. Ligands, they can be negative ions, they can be positive ions, or they can be neutral ions. Okay, not positive, negative or neutral ions. Ligands are Lewis bases. What are Lewis bases? They can give a pair of electrons. Then, central metal atom or ion is Lewis acid because they accept a pair of electrons. Understood? Yes. So, classification of ligands and the other things, let us see in the next class. Okay, fine. So, any doubts up to here? Application otherwise. Just go through the things. Okay, so we have discussed about the ligands. Okay, so what are ligands? We have seen. Okay, so next is let us see what are the types of ligands. So let us see the types of ligands. We will see the types of ligands also. Hmm. So basically, so depending upon, so what is the donor ligand? Ligand should give what? It should give you. Huh. So what is the what ligand should give? Ligand should donate at least one pair of electron, right? So ligand metal is there, ligands are there. So what ligand should do? It should donate a pair of electron, and it should form the coordinate bond. Okay. Now, so the types of ligands, how you will classify the types of ligand depending upon the number of donor atoms. So depending upon the number of donor atoms present in the ligands, they are classified. How they are classified? Okay. So depending upon the number of donor atoms present in the ligands, so how they are classified? They are classified into mono or unidentate ligands. Okay, mono or unidentate ligands. Then bidentate ligands. Okay, bidentate ligand, that is poly or multidentate ligands, and amphidentate ligands. Okay, so these are the classification of ligands. So type of ligands. So depending upon how many donor atoms are there. What do you mean by donor? It will give electrons. Donor means it will give electrons, right? So how many donor atoms are present depending upon that. So your ligands are classified as monodentate or unidentate, polydentate or multidentate, or amphidentate ligand. So these are the three types. So let us see with monodentate ligands first. Okay, let us see with the monodentate ligand. So a ligand, okay, a ligand which is bound to a metal atom, okay, or a metal ion through a single donor, donor. So this is a metal and H2O. Okay, H2O is your ligand. H2O is your ligand. So in the ligand, so the oxygen is the this what donor atom. Okay, so this is giving the pair of electrons to the metal. So what is happening here? The point of attachment is only one to the metal. Okay, so it is called as what? Monodentate. Okay, it is called as monodentate or what? Monodentate or unidentate. Unidentate. Okay, so what is monodentate or unidentate? So one donor atom or one point of attachment is present, okay, with the metal, okay, and it forms one coordinate bond with the metal at only one side in the complex. So what can be the other examples? Okay, so examples are neutral ligands and negatively charged ligands. So which are the neutral ligands? So the examples of the unidentate ligands, please write these. Okay, so the neutral ligands examples are your NH3. Okay, so your ammonia. Okay, this will get linked. Okay, then is your water, that is aqua. So this will linked, oxygen will get linked. Okay, then is your carbonyl. Next is your carbonyl group. So this will linked. Okay, this will get linked to the central metal atom. Then is your nitrosyl. Okay, next is your nitrosyl. So your nitro. So let me write here the names. Please write these down. Amine. This is aqua. This is your carbonyl. Okay, and this is your nitrosyl. Okay, then is your C6H5N. So this is what? So your nitrogen will, it is your pyridyl. Pyridyl. Okay, pyridyl. So these are the unidentate or monodentate ligands. So what are monodentate or unidentate ligand? Only one donor atom is present, and one time only one attachment is possible. Okay, to the central metal atom. Okay, so this is called as monodentate or unidentate. So these are examples of neutral ligands. So let me give you the examples of negatively charged. Okay, negatively charged, negatively charged ligands, negatively charged ligands. So which are the examples of negatively charged ligands? First is the cyno group. Okay, so in this, your C is your attachment, then is your hydroxo. Hydroxo in that OH. So this is O is your this, then is your thiocyanate. Thiocyanate SCN minus. Okay, your sulfur is the attachment. Then halo, halo group, that is X minus. So your okay. Then nitro group NO2 minus. So your nitrogen is the attachment. Then is your oxo group O22 minus. So your is the attachment. So these are the examples of your mono or unidentate ligands. So neutral ligands and negatively charged ligands. Okay, so this is the first one. So so how we are giving the classification of ligands based on the number of donor atoms, right? So first one, what we have seen is a monodentate or the unidentate ligand. So only one donor atom is present or only one point of attachment is possible. Okay, it can form only one coordinate bond with the metal ion at one site. Is it clear? So we have seen the first classification, that is monodentate or unidentate ligands. Okay, so next one. Okay, next one is your polydentate ligands. Poly. Uni means this itself tell you uni means one, mono means one. Poly means what? Poly means more than one, right? Poly means more than one. So poly means more than one. So when you have two or more donor atoms or point of attachments, then they are termed as uni, that is poly or multi-dentate ligands. Okay, so when you have two, that is two or more, okay, atoms, donor atoms, when you have two or more donor atoms or the point of attachments are more, okay, then they are termed as polydentate ligands. Now this polydentate ligands, okay, so a ligand in which a bond, okay, ligand which is bond to a metal atom through two or more donor atoms, okay, it is called as polydentate. Now, how these are further classified? These are classified as bidentate ligands. Okay, these are classified as bidentate ligands. Then tridentate ligands. Then tetradentate ligands. Tetradentate ligands. Okay. Then fourth one is pentadentate ligands. Pentadentate ligands. Then fifth one is hexadentate ligands. Hexadentate ligands. Okay. So, okay. So this much you will see. So depending upon the type of attachment. So if there are bidentate means what? Bidentate means two donor atoms. Okay, two donor atoms or ions are present. Tridentate means three. Tetra means four. Penta means five. Hexa means six. Okay, so depending upon, so your two donor atoms will be there in bidentate. In tri, three. So three attachments. Four, tetra, four attachments. Okay. So here you can see, so these are, can you classify now? What is this? This comes under what? So these are the types of ligands. So tell me. So you can see the mode of attachment is how many here? Two. So this comes under bidentate. Okay, this comes under bidentate ligand. This is also mode of attachment is 2. So this is also bidentate. Here the mode of attachment is 2. So this is also bidentate. Here it is 2, bidentate. Here also it is 2. So it is bidentate. So these are the examples of what? Bidentate ligand. Okay. These are the examples of bidentate ligand. Fine. So these are the examples of your bidentate ligand. So I understood what is the this. So depending upon the type of donor atom, so depending, so whether if there is 2, 3, 4, 5, 6, so these are classified as bidentate, tridentate, tetradentate, pentadentate, and hexadentate. So the examples of each we will discuss it in the next class. Is it clear? So your okay, fine. Others. Okay, fine. So, so everything is clear. So in today's class, we have discussed about what are coordination compounds. Okay, what are addition compounds? What are the types of addition compound? In type of addition compound, we have seen what are the double salts, what are the examples of double salts, what are coordination compounds, what are the examples of coordination compound. Then we have seen some of the important terms which we are going to use in coordination compounds, coordination entity, central metal atom, then ligands. Then we have discussed about what are the types of ligands. So in today's class, we have completed monodentate or unidentate ligands. Then just we have seen what are polydentate or multidentate ligands. So when you have two or more donor atoms or the point of attachments are more, then we termed them as monodentate ligands. Okay, so depending upon the type of, depending upon the number of donor atoms, these are further classified as bidentate, tridentate, tetradentate, pentadentate, and hexadentate ligands. So in bidentate, you have two donor atoms. In tridentate, you have uh, 3, tetra 4, penta 5, hexa 6. Okay, so these ligands, okay, and the examples we will see in the next class. Is it clear up to here? Okay, fine then. So by this, we shall end the session here. Okay, uh, yes, fine. So we'll meet in the tomorrow's class. Thank you. Have a good day.